Hi guys, we're going to look at work. It's our next unit that we should be working on. And so we're going to go over a few of the basic questions and make a couple of videos for you to check this out. So to start off with, we left off with force making a mass accelerate. So what did you want to think about there is that when an object accelerates, it must be moving, okay? And if it's moving, remember the distance between each of those changes, you get greater and greater distance. So there's a relationship between force and distance, and that is the work relationship. So we can say that when work is done, a force will move an object some distance, okay? The SI unit is a joule. All right, and 1 joule equals 1 Newton meter, okay? And so the only really trick to this or thing to think about is we must be looking for the force that's parallel to the displacement. Now, this is not force parallel from force normal on an incline. This is simply the force that's parallel to the displacement. So it could be a different trigonometry function to get that. So one of the first examples are like if you lift an object, then you're doing work over gravity, okay? All right, and then maybe if you push an object, you might be doing work applied force, right? You're doing a work from some applied force. Maybe you pull an object, or maybe you're doing work against friction. All right, the big non-example is the one that we need to take a moment to look at. When are you not doing work? Well, you're not doing work when force is no longer parallel to displacement. So when the force is perpendicular to displacement, there's no work done. So like in this example, when you're carrying a box or when you're carrying something, there's no work done. All right, so if we look at that, we can start off and we can say that the weight of the box, not work, the weight of the box is going down, so the force you apply is up. So there's our force there. And then as we walk with this box has a displacement in that direction. So you can see that the force is no longer parallel to the displacement. So we have no work done. So it sounds unusual and it doesn't necessarily fit the conventional thinking, but when you carry an object, there's no work done, and it's because the force that you're using to hold the object is not in the same plane or not parallel to the force to the distance. And so we see another example of that, okay? When we look at this guy here is pulling this box by some type of rope, and he's applying a 20 Newton force at 30 degrees. So, you know, again, work is the force parallel to the displacement. And so is the 20 Newtons parallel to the displacement? And the answer to that is no. So what forces are parallel? So we can come right here and we can break this into our components, right? We find the F of X force. And then going up, we have our F of Y force, okay? So now we have the applied force of 20 Newtons, the F of Y force, and the F of X force, the components of the 20 Newton force. So which one of those is parallel to the displacement? Well, in this case, the force parallel to the displacement is the force X. And how do we get the X component? We get the cosine theta times the force. So again, don't confuse that with parallel on an inclined plane. This is the force parallel to the displacement, and we're on a horizontal surface. So to continue to solve this problem, we just simply go, the work done on this box is equal to the cosine of 30 degrees times 20 newtons, and then we see the displacement, which is recorded here, of 5 meters. So the work done on this box, we'll just take our calculator here, and we of course go 30 cosine times 20 times 5 equals, and we get 86.6 newtons. All right, so that's the work done on that box. Excuse me, not 86.6 newtons, but 86.6 joules. So here we have examples when you're lifting or pushing. We have a non-example. when the force is not perpendicular. And then what if the force is at some angle? If the force is at some angle, you have to use the component force that is parallel to it. All right, so let's look at the work done by friction or the net work done on some object, okay? So in this case, we have our object that's being moved here, and it has constant velocity. So this object is moving with 20 Newton force at constant velocity. Now that's important because at constant velocity, the force of friction is equal to the force applied. So our force applied is 20 newtons. That would mean our force of friction is also 20 newtons. And again, that's because we're at constant velocity. It has to be in equilibrium. So what's the net work done on this box to move it 5? So you remember, net work is the net force. So work equals the net force that's parallel to the displacement. Well, our force net in this case is going to be 0. 20 minus 20, because those vectors are going in opposite directions, it's going to be 0. So 0 times 5 meters, we have a work net of 0. So you might be thinking, in this case, there's no work and the box moves, but that's the net work is 0. So let's go back and look at that a little bit differently. And we can say the work done by the person. Well, that's the force of the person times the distance. So the work of the person would equal 20 times how far we moved it, 5. And that would equal 100 joules. Okay? All right, so now, is there anything else doing work? Well, remember we had some examples there about, can friction do work? Well, friction is a force, and it occurs over some distance. So over here, we can look at the work done by friction. And that's going to equal the force of friction times the displacement. So that's going to be 20 newtons times 5 meters. But we got to be careful here. If the 20 of the force applied is a positive, then the 20 of the force of friction is a negative. So the work done by friction is going to equal negative 100 joules. All right, so then if we just simply take the net work, so we take the negative 100 and the positive 100, we get back to our net work of 0. So these are the basic problems on calculating work, okay? And so, of course, you got a lot of different scenarios from there, but we'll start with that one. So at this point, you're going to work a few problems calculating the amount of work done, calculating the net work. When you're calculating net work, be sure to take into consideration situations where sometimes the work is positive, and then sometimes the work could also be negative. All right, guys.